Oh, hi everyone. Welcome to our first virtual lecture. Today is May 12th. As you may be aware, we will be meeting every Tuesday 10:50 to 12:30, and Thursday same time. Today is our first lecture, and typically I'll be opening the lecture room 10 minutes to start time. I see still there are some folks who are trying to join the conference, and for some reason, I don't know if they cannot or their computers, but nevertheless, please be checking the announcement, checking your UNF email account for any update, in particular the credentials you need to join the conference. For example, the meeting ID as well as the password for security. I will send maybe in less than 5 hours. I'll send you the meeting ID as well as the password. All right. Please feel free to use the chat feature on Zoom. If you have any question, I will respond, or alternatively, you can stay behind, send me an email after the lecture that, if you have any concern or if you have any question, all right? Somebody is saying that they can hear me. Can you hear me? Can you hear me?
Yes.
Yes, somebody saying that they can hear me. All right. Probably maybe you need to check your connection and make sure that or maybe your audio on your computer or laptop, or maybe even the iPhone or any smartphone, you can still download the Zoom and be able to join us. I'm gonna share my screen and walk you through the course on Canvas where staff are. Allow me to share my screen, and you will see my screen home page for our course. This is probably what you saw. This is probably what you saw when I published the course. You'll see that on the left column, I do have some tabs. I'll recommend that please familiarize yourself with these tabs. I'll be putting tab on this tab for now. This is what I have, the mastering chemistry assignments. I do have the course syllabus, and the modules here. Modules are arranged according to not the weeks, but according to the chapters in the text. All right. I'm assuming you are able to use the credential or the link through MyLab and Mastering to get the access code. If you haven't get the access code, please request for temporary access code, which is good for 14 days. And remember, all the work you will do on the temporary access code will not be lost. Once you get your access code, all the assignment will be transferred. It will still be on your account. So if you don't have the money to pay right now, please do request or sign using temporary access code. It's good for 14 days. All right, and I hope by 14 days you will have your access code, which you will use to access the assignment as well as the e-text. That means the electronic version of the text to read the required chapters. First thing, let me walk you through the course syllabus, and I'm not going to read everything. I know you have this document, and hopefully you read each and every section in the syllabus. We'll be meeting every Tuesday and Thursday, 10:50, but these are my office hours. You can send me an email requesting for special appointment. I'll be glad to help you if you have any concern or question, okay? So these are my Zoom office hours. I want to just right track a little bit. I have a TA, teaching assistant. All right, I have a teaching assistant. He might get in touch with you or might schedule like tutoring session. I know you may be wondering how will I get help now that we are not on campus, and somebody may be wondering how will I access the library or who will help me. I'm just by myself. I've added somebody by the name Justin. He will schedule tutoring session, and please make use of those available resources if you have any difficulty. So nevertheless, these are my office hours. Please feel free to email me and I will be more than happy to help you. All right. This course is intended to prepare you for CAM 2, unless this is your only course required for your program, but mainly it is tailored for those students who will proceed to CAM 2, General Chemistry and Quantitative Analysis 2. Our meeting will end on July 31st on Thursday. I'll give you an update on what will go on that day. Here are the required materials. You'll need the access code so that you can access the material online. You'll also need a calculator, all right? There's some calculation you'll encounter during the course of the semester. Please, any calculator, I'm fine with it. Somebody asked me yesterday if TI-84 is good. That's fine. I'll accept that. Please remember to familiarize yourself with your calculator so long as it is capable to handle the square root, all right, logarithm and so forth. Because at some point you use these features. Let me just see if I can mute. I can hear some background noise. Let me mute everybody. See if you can. I've muted everybody, so get rid of the background noise. So you're gonna need a calculator. You will need a Google account. If you don't have a Google account, please do have one, because at some point you may request for lecture recording and I'll send you through YouTube. I have a YouTube channel. I'm recording the lectures and I can make it available to you through Google account. You should also have a reliable internet connection, and the reason why I request this webcam is for you to take the exam. There will be a lockdown program, lock your screen, and that will not work unless you have a webcam. Please let me know if you have any difficulty with that, and I'll see how best I can accommodate you with the requirement. Fast forward to how you will be access or how the points will be calculated at the end of the semester. There is the Canvas syllabus check, all right, which means you'll have to read the course syllabus each and every section. There will be 2 points towards the final grade, okay? You'll see that on the grade book. I'm gonna talk about the dynamic study modules once I dive on the MyLab and mastering 5 dynamic study modules, what 8 points towards the final grade. Out of 10, all right, out of 10 homework assignment for each chapter, I intend to cover 10 chapters. Only 9 will count to your final grade. I will, all right, I will drop the lowest, okay? I will drop the lowest. So somebody is asking if the lab grade is incorporated in this grade. The lab is separate, all right? And that is why you will see in, excuse me, you will see in, let me see if my stylus is working. You will see in some courses, it is written CHM 2045. C, that means combine, and then there is CHM 2045L, that means lab, and this course is CHM 2045, which means there is no lab component in this course, so it's separate. All right. Somebody is asking about the microphone, so hope you can hear me. I hope you can hear me. Can you hear me? Somebody's having problem with the microphone. Check your microphone.
We can hear.
Is it me?
No, we can hear. It was just when someone else's mic was on earlier.
Oh, okay. All right. So I hope I answered the question on if this lab is combined with the, if this course is combined with the lab. It's not combined. That is a good question, because you may apply for a professional program down the line and they'll say, oh, you should have taken Chem 1 with lab. That means if you take this course and you fail to take the lab later on or concurrently, you will be forced to take the lab again. All right. So this is separate from the lab section. It is purely the lecture, and it will show up in your transcript as CHM 2045. No C or no L. C means combine, L means lab, and just plain 2045 means it was only lecture with no laboratory component on it. So back to the creating criteria, 9 out of 10 homework, all right? 9 out of 10 homework will count towards the final grade. It will be average to 15 points. Quizzes, there will be quiz after every chapter, all right? And the quizzes will be average to 25%, and the lowest quiz will be dropped. Lowest quiz will be dropped. Midterm exam, it is in the core syllabus, all right? I have the dates for midterm. It's just like exam. It's not like we are in the middle of the exam. After the first 3 chapters, for example, we will do exam 1, or you may call it midterm, or exam 1, exam 2, and so forth. Out of the 4, all right, out of the 4, only 3 counts towards your final grade. And then the final comprehensive exam will be on Thursday, or will be scheduled on the last week of the semester, all right? Tentatively, last week of the semester, it will cover chapter 1 up to whatever we'll have covered at the end of the semester. All right, if I have say that you know, the final comprehensive will not be dropped. All right, it will not be dropped. So please take note of that. There will be a dynamic study model, as I say that, Canvas check, you'll see that assignments. Please read each and every policy here. I don't want to read each and every item here because of time factor. In case says you have some dispute, or if I fail to record your quiz, or maybe homework assignment is not reflecting, or if there's a typo error on one of the question on assignment, please let me know and I will fix. Don't wait until the end of the semester. Here is the grading scale. A, I'll have A 91 to 100, A minus 87 to 90, B plus 86 to 84, coming down all the way to anything below 59 or equal to 59 is an F. However, there is a grade of incomplete. If a student has been participating and having a grade of C and above, and then we will work on the incomplete grade. All right. You will be checking your progress by looking at the grade Boop. All right, this is where you'll find the create. For example, right now, you may see that there is introduce yourself. I'll go in and create all this, what you see here for those who have turned in their work. Make sure you do the assignment. Going back to assignments, all right, or even before I go there, let's see how the exam will be administered or how the chapters. This is what I wanted to show you, okay? Tentative schedule right here. You see, this is the tentative schedule. I intend to do or start chapter 1 today. And by June 4th, we will take the first exam, which will cover 1 through 3. If by this date, I'll not have covered all the chapters, and then the exam will only cover up to a certain or up to whatever we will have covered by that day on June the 4th. In between here, there will be a quiz. There will be a quiz. There is exam 1, exam 2, exam 3, and all the way to exam 4 in the end. Please check the dates, mark on your calendar or your daily planner when we will be doing the exam. I will not change the exam dates unless otherwise it will just remain the same. I may give you some sort of bullet points on the study guide that you need to know this, you need to know this as we go along as far as the exams are concerned. So make sure that you know we have we have exam 1. All right, there is exam 1, exam 2, exam 3. All right, and there is the final comprehensive exam, final comprehensive exam. The schedule can change. So this is the grading scale. Any question to this point? Any question? Any question? Somebody asked there are 3 midterms, you saw that. When will the quizzes be? I'll let you know, I'll post, on the announcement so that you don't miss. You'll see on your email. Geneva, there are 3, as you saw there are 3 exams. How do we complete the Canvas syllabus? It is, I'll give you this, there is something you will sign for check. There is something I'll assign you that you will sign and send it to me with instruction that, I've done this, and then you submit to me as a PDF and you will get that. So that take care of how you will complete the syllabus check. There is a form, I'll send it to you. Kerry, will the lowest midterm exam be still dropped? Somebody asked me if they will be dropped. Yes, the lowest will be dropped. The lowest that will be dropped. Let's see, any other question? So the quiz, I'll send you the email on when the quiz will be available. Make sure you have, you'll follow the direction. There'll be direction for each and every quiz, quiz. Any other question?
On your syllabus, it says that you only take 3 midterm exam grades and the final, but there's only 3 midterms. So how are you dropping the lowest one if there's only 3?
Let's see. The problem maybe I failed to put the 4th. They should be 4th exam. They should be 4, and I picked 3. I'll put an updated date on when will be exam 3 and 4 and let you know where it's gonna be. Okay. So this, if it remains 3, and then all these 3 will count. If not, if I don't add the 4th one so as to give you the leverage on where you will be, and then these three will count. This is 1, this is 2, and this is 3. If I don't add the fourth one, and then the 3 will count towards the final exam. Okay. Somebody say oral exam through the analog. Yes, somebody is asking through the analog, either analog or look down. You have to have the look down screen. There are certain times we have to complete the midterms. I will make sure, because of the condition where we are right now, you know, I want to make sure that you have to complete the exam during one sitting. Say, for example, I can make the exam available and you have maybe until Sunday. Not that, oh, the exam is available from 1 o'clock to, or I mean 10:50 to 12:50. I cannot have that because of, you know, some situation, maybe internet will just shut down on you in the middle of the exam, but I'll have just an extended time that you have 2 days or 1 day to complete the exam. That way, you know, it will take care of those unforeseen circumstances, which I saw, or maybe you encountered this past spring. Yes, you'll have to use a calculator. Yes, you'll have to use the calculator provided. Any other question? So remember, you can't complete the exam within one sitting. I will give you an extended time to, not extended, but a time frame that you have to complete during one sitting, so that if something happened, you know, you still have time to do that. Yes, somebody is asking, are there any assignment of right now? Yes, there are exam assignment. If you look at my lab, and this is where the assignment will be posted. I haven't made it available because I have not started yet. But if you go to the assignment for my lab and mastering, and get to, you know, assignments. This is my window as an instructor, but yours will be slightly different. I do have dynamic study module right now. I believe 4, yes, 4, and all these. Right now, you may not see the due date, but once I make it available, you have. So see, these are the assignment already available throughout the semester. But since we have not, you know, or have not covered the chapter, I don't have the due date. So I may make it available, but once I'm done, say for example, chapter 1, once I'm done with chapter 1 is when I make the due date that you should be done with that. Somebody is saying that which one do we have to buy? Is it 75 or 120? Please check if the difference between the two. I haven't checked this. Somebody asked me this morning if they can buy the 120. I say yes, 120. Probably this 75 you may not really, it may not be bundled with the access code. Please check, because if you buy this, it may not come with the access code. But if it comes with the access code, and then it is, you need the one which comes with the access code. But let me make sure before you spend money on, you know, on 75. So somebody is saying that 75 does not come. You need the one which comes with the access code and it is bundled with the textbook. Otherwise, you may have just the access code, but doesn't give you what? Doesn't give you the access to the e-text. That means you'll only be doing the assignment and will not help you. Yes, exactly. Somebody is saying that doesn't have that. So I'll recommend that by the 120, it is bundled with the e-text. You'll be able to read the chapter. You'll be able to highlight. If need be, you will be able to see the simulation, all right? And that is what it is. So coming back to assignment, what I want to do is just make them available until the end of the semester. But once I'm done, I will impose the due date. Yes, I'll make it available for you, but the due date, once I'm done, Carrie, once I'm done with the chapter is when I'll make it the due date, but they will be available. But in case you want to practice with it, Once we are done with the due date for to record automatically on gradebook, I'll make it available as practice. Say, for example, chapter 1, once it's due, it is graded. You have the grades on the My Grade book on Canvas. I will reassign the same chapter as practice, and it will not affect your grade on Canvas. That will be helpful, so I'll make it available. I can also make the study module for practice. You know, the difference, or this is just to give you, you know, the difference between study module. It tests how well you are for analytics. So that will help you. I'll assign you for practice. You will see more assignment here. Some will count towards your grade, but when you see as a practice, I'll send you that. That will really help you out, okay? So I think that answers the question when somebody was asking if I have already the homework. Yes, I do have, and I will make them available today. In fact, the first 3 for first exam should be available. If you are ready and you know what you're doing, you should be able to do that. Eric, when do we do the assignment? Do we do the assignments past due date? You'll have to check the policy on the past due date. All right, the past due date on here. Yes, I'll reassign the date here. When I was setting up, I just put right here. This, Eric, these 2 assignment past due date is meant to introduce you to the system, the MyLab, My Mastering. How does it work? So I'll reassign it with the correct date so that you know you will be able to understand how the system works. Understand how the system works. All right. So that is the MyLab and mastering. I'll assign you. Is there an SI support? Yes. If you join Sarah, if you join, I think you are, is it support instruction or TA? If you're talking about the TA, I do have the TA. It's enrolled on the system. He will get back with you momentarily, schedule study help session. All right. Yes, I do have the TA, teaching assistant. If that is what you are asking for, Sarah, that is, I believe that is what you meant by SI, support instructor. There is a teaching system. All right. So if there is no other question, right now, let me see before I get started with chapter 1, measurement and uncertainty. All right, let's see. Yeah, somebody is asking before I proceed, Scout, do the past assignment counts towards our grade? Yes, you need to work on that. All the assignment counts towards your grade. Please do that. You will see on the grade book. Anyone port 75 package, that one is, this one doesn't come with, $75 one doesn't come with the e-text. The $75 one doesn't come with the e-text, and I highly recommend that you should have access to the e-text. Otherwise, it will be a challenge just to do the assignment of at the top of your head. You know, I would recommend that buy the 100 and buy $120, and it's gonna help you in taking the course and being successful. The $75 one is for other institutions or other instructors which may use any other resource out there, but they recommend their student to take the mastering chemistry or MyLab and mastering chemistry assignment, but they use any other resource. But for us, we will need to have access to the, you need to have access to the e-text. For each chapter, all right, for each chapter, you'll have an overview, all right, which kind of like summarize. Let's go to homepage for overview, or rather the modules. If you look at the modules, I do have overview for each and every chapter, and it just give an overview of what it's all about. You click on each overview, it summarizes the chapter. All right, any question? There's no question. I'm gonna just dive into chapter 1, and right now, I want to get started with measurement, matter, energy, and measurement. Enlarge my screen a little bit. I'm gonna summarize this. If you have any question, please use the chat feature on Zoom conference and I'll post. If you have any question, are you a PowerPoint posted on Canvas? Yes, they are on Canvas. If you go to module 1, all right, there is the PowerPoint tab or file at the bottom on module 1. You should see the lecture PowerPoint. Right now, I have chapter 1. I'll make chapter 2 and chapter 3 available today or tomorrow before Thursday. Somebody's asking about the assignment. Yes, I'll correct the due date for the those past due assignment. And when I was just setting up, I forgot to check the date for all those due dates. All right. Right now, let's get started with our first lecture, which is on matter, energy, and measurement. These 3 terms here, they are not really new to you. I know you have, you have covered the concept on matter, even energy and measurement in Introduction to Chemistry, or if you are taking the course, this is something easy for you. In fact, some instructors have their students read chapter 1 on their own, all right? Before we look at the matter, energy, and measurement, why is chemistry so important? Some of you may be taking the course just because of the program. Maybe you are a civil engineer and you are required to take Chem 1 and that's it, But to me, I believe chemistry is essential in every field, in every career. At some point, you should have a basic understanding of chemistry, right? You should have a basic understanding of chemistry. Some texts term this subject as the central science that virtually we will need in all areas, all right? And chemistry is simply the study, all right? It is simply the study of transformation of matter, all right? Study of matter and its properties. And you know, matter is anything that has what? That has mass and volume. We're gonna define that later on, that matter is anything that has volume, all right, and has mass. So this time here, you should have mass, all right, mass and what? And volume. Anything that has mass and volume is matter, right? There are 3 states of matter: solid, liquid, and what? Solid, liquid, and gas, which I know you already know that. And though we have 5, We're not going to look at the 3. Now, for the sake of this course, if you are asked which one of the following is considered as the central science, and you are given chemistry, biology, or physics, just give me chemistry, all right? I know maybe when you go to biology, they might also say biology. When they go to, when you go to other courses, they might also consider that as the central, but chemistry is the central of, is the central science. It's the fundamental of many science-related fields. For example, right now, in case you didn't know why they recommend to wash your hands with soap because of the coronavirus, the chemistry behind that is the protein coating of the virus. All right, the soap will digest the protein coating and it will die. You know, otherwise they could have just recommend any other detergent. But why so? Because of the chemistry tests on the protein coating of the virus. That is chemistry right there. Even to develop the vaccine, all right, even to develop the vaccine, they will need to understand the chemistry of the virus, all right? They need to understand the chemistry of the vaccine before they administer on people. They have to put it on clinical trial and so forth, and a lot of chemistry goes in there. And it's not only in pharmaceutical industry, even in agriculture, even in environmental science, we need chemistry. So please read again in the background why chemistry is important. There is a paragraph or so I have on the overview, all right, on the introduction part of overview, why chemistry is essential. I defined matter earlier on as anything that has mass and text space. Please don't take this, don't let this term here as mass and space confused. This is basically volume, all right? This is what I do have here is volume, anything that has mass or volume. Question I see a lot from here to test you whether you know what matter is which one of the following is an example of matter? And then you are given light, and then you are given maybe textbook, maybe you are given a pen, or maybe you are given, you know, anything, or even your clothing. You should be well-rounded in giving examples of matter, but having a general understanding of what matter is, and then you shouldn't have any problem in citing example. You can give any example in terms of you know what matter is. All right, let's see the states of matter. We have 3 states of matter, and matter can be classified either using the state or using the composition. This is where we're gonna talk about solid, we're gonna talk about liquid, we're gonna talk about gas. Let me just show you, I think it's on your way. Let me see if I can put this right here. So this is what I was saying, that matter can be classified as either solid, liquid, or solid, liquid, or gas, solid, liquid, or gas. As for solid, liquid, this is the state. Sometimes state is phase, liquid phase, solid phase, or gaseous state, all right? The composition, this is when we're gonna talk about the pure substances versus what? Versus mixtures and so forth. We're gonna come back to each one of them, but we're gonna start off with the states of matter. We have solid, liquid, and gas. It's not something, these states, they are not new to you. I know you know they are. You can easily list them, all right? You can name them. Now the question is, you should be able to state the properties of solid, properties of liquid, properties of gases, all right? Here are just example of H2O in different states, This, all right, this diagram here, carries an important message which you need to be able to understand. In other words, when you see these states right here, liquid, solid, and gas, any matter can exist in any of those states, all right? Any matter can exist in any of those states if you change the temperature. Let me have solid here, let me have liquid here, and let me have gas right here. You should be able to note the changes which accompanies change of state. If we change the temperature, all right, we're gonna have what we call melting. It can melt liquid, or it can freeze, all right? Freezing, this is change of state, or it can go to liquid to gas, and this is vaporization. That means it's gonna vaporize. And condensation, all right? It can condense, condensation, right? Just spelling, coming back to liquid. And from solid, going straight to gas without going through the liquid state, we call this sublimation. You gotta know these states right here. And coming from gas to solid, without going through the liquid state, we call this process here deposition. I'll recommend also during, when you are organizing, studying, either you can use scratch paper, you can use index card. If you look at this diagram I have on my whiteboard here, that's how I've configured my mind that what is condensation? Might be something new to you for the first time. What is sublimation? And by the way, I do have right here, this is what I have at the bottom, deposition. That means coming down from gas to solid without going through the liquid state. So that's what I was saying, that here, there is an important message underlying between the three states. How comes that this state, when will these changes take place? When you change the temperature. If you remove an ice cube from the freezer, temperature will change and it will melt. If you boil water, it will change from liquid to gas, and that has to do with the temperature, changing of temperature. We're gonna come back to those terms later on, just to give you a heads up on what those three states are: solid state, liquid state, and gaseous state, all right? Now going to the second part of classifying matter. Apart from classifying matter as solid, liquid, or gas, matter can also be classified based on the composition. What is it made of, all right? We have mixtures, which can be homogeneous. Homo means one phase. You have two things there. Homo here means one. This one means one. So homo means one phase. That means you have only one, you see as if it is one. For example, here is the H2O. If I dissolve 1 gram in this amount of water, all right, not excess, just 1 gram, it will dissolve. Sugar or table salt, it will dissolve and form homogeneous. It can be 2 or more, all right? It can be 2 or more components in it with one phase. You see it as if it is one. Homogeneous mixture, once you know the meaning of homogeneous and how this, you should be able to cite examples. For example, I've just given you a mixture of salt and H2O, homogeneous mixture. There is alloy, all right? Alloy, all right, alloy ring. This is 2 metals mixed together homogeneously, but they don't form chemical bonds. Air, all right? Air is an example of homogeneous mixture because in the atmosphere there is nitrogen, there is CO2, there is H2O in gaseous form, there is carbon dioxide, All those are homogeneous, but we cannot see. We just see it as if it is one, but they don't form chemical bonds. Maybe wine, all right, is an example of, all right, wine. I'll just give you an example, just few. Wine is an example of homogeneous mixture. There is somebody can think of, use the chat feature. I'm just trying to see if you can, you craft. What is an example of a homogeneous? Let me see. Who's gonna respond fast? Let me see. Nobody? Am I here by myself? Let's see. Example of a homogeneous mixture. Smoothie, yellow, steel. Yes, I like that. Apple juice, thank you. Oh, yeah, people know this, yes. Those are examples of homogeneous mixture. You know what I mean. So I'm gonna ask you, which one of the following is an homogeneous mixture? Heterogeneous mixture means more than one. Hetero means hetero, right? Here, hetero means two or more faces, all right? I can have sand here and, mix it well. After some time, sand will separate, it will go down, and I just have the liquid H2O. That's an example of heterogeneous mixture. Concrete is an example of a heterogeneous mixture. Take granite on the kitchen. If you have a granite, it's an example of a heterogeneous mixture. Salad, yes, that's a good one. All right, fruit cake. All right, I like that. Fruit cake, cereal. Oh, I'm hungry. Everybody, are you hungry? Everybody's studying food. Trail mix. Oh, good. All right, good. Sand and water. I like that. Sand and water. Those are heterogeneous mixture. Even oil and water you separate into two. I may have even ethanol and, no, not ethanol. Ethanol, alcohol will mix up with that. Ethanol will mix up with that. So, and then now coming back to now mixtures elements. These are the elements on the periodic table. Element on the periodic table fall under this category. And of course, when elements combine in a specific ratio, they form compounds. They form compounds. There is a flowchart in the text, and here is the flowchart on how matter is, or how you can classify a matter. You may ask yourself this question, that you are given a specific example. Is it uniform? If it is no, then must be a heterogeneous mixture. If it is yes, it might be homogeneous mixture. Then you ask yourself, does it have variable composition? If no, then pure substances, or heterogeneous or homogeneous, which is a mixture of solution and so forth. We're gonna come back to this. Mainly for this course, we'll be dealing with elements, we'll be dealing with compounds with respect to periodic table. Now, let's see, what is the difference on the flowchart? Let me pack up. You see here substances. Forget about the other part. Substances here, pure substances. That is where we are with respect to classification of matter. A substance has distinct properties and composition that does not vary from sample to sample. Water H2O is a pure substance. It will not vary from sample to sample. Water in California, water in Canada, Australia, or wherever, it will not change. Its properties will remain, and we're gonna come back to properties later on. Two compounds, all right, two types of substance, or rather elements and compound. Two types of substance can either be what? Elements and compound. You could be wondering what's the difference between these two. And these are, by the way, when you see the board, terms in lecture presentation and even in the text, those are the terms you should be able to divine, you should understand. Otherwise, if you don't know these terms, it will be complicated. What's the difference between an element and a compound? I'm gonna use these as, these are elements, hydrogen and oxygen, even sodium, and chlorine, all right? Anything you see on the periodic table fall under these pure substances element. But when elements combine in specific ratio, all right, they form compound. Specific ratio is, example is H2O, this is a compound. You may not know, all right, you may not know the chemical or the name for this. You may not know the name for this, but it is a compound because I see, this is what I meant to, you don't see that? This is what I do have down there. CO3, this is a compound. That is a compound. Sodium chloride, NaCl, this is a compound. When elements combine in a specific ratio, they form compounds. And that is why we have here on the flow chart, does it contain more than one kind of an atom? If not, it's an element on the periodic table. If they combine in more than one ratio, then it's a compound. That's how you differentiate an element from a compound. It cannot be broken down into simpler substances. What could be the question in an exam? It could be, which one of the following is a definition of an element, or how do you define an element, all right? And then you got to have it. Compound is a substance that can be decomposed into simpler substances. For example, CO2, if we pass electric current through water, it will, electrolysis will take place. We will separate hydrogen from oxygen, all right, through electrolysis. Any question? Any question on classification of matter as, or pure substances as compound and elements, compound and elements? All right, let's move forward to, fast forward to elements. If you look at elements, let me back up here and see the relationship right here. Elements right here, an element, for example, an element that is sodium is made up of atoms. It is made up of atom. And what is an atom? When we say building block, we're gonna look at in chapter 2. We will look in chapter 2 in details and how we ended up with an atom. But for now, let's understand it is the simplest, indestructible part of matter. You cannot destroy it, building block of matter. Each element is made up of a unique atom, and can be more than one, but compounds more than two different elements. That's just to differentiate between the element, atom, and compounds. Element, atoms, and compounds. In chapter 8, we look in details on how chemists represent atoms using balls in valence electron repulsion model. Chemists use spheres to represent atoms, and the color coding also play a role. For example, rule of thumb is oxygen is always red, hydrogen is always white, and carbon is always black. To give you a heads up on some of the diagram you will see in the text. The composition of the element and its composition, generally in nature, all elements are not available in equal proportion. If you look at the distribution here, we have oxygen being predominant makeup on the earth crust. 5 elements, you need to know what they are. Here they are about 118 named elements. The 118 element you see here on the periodic table, and if I were you, I'll start off with by just starting to memorize, the first 20 elements, and then you just keep on adding until you are well-rounded with the elements on the periodic table. most, and I don't expect you to memorize all of them, but the first 20, once you master, you increase to 30. Chemical what? Names and symbols, because that's where we are heading to, so that down the line, it will be much easier for us to move forward. And here are just few elements we will see in details in the periodic table in chapter 2, the chemical symbol, as well as the name. The most misspelled element on the periodic table is fluorine, F for fluorine. What is the definition of a compound? All right, a compound is, somebody is asking what is the definition of a compound. A compound, you can define it as a pure substance first, made up of 2 or more elements. In other words, you define a compound using element, but you cannot define an element using compound. Somebody is asking will you define a compound again? A compound is a pure substance made up of 2 or more elements. Sodium is an element, chlorine is an element, but when we have this is a pure compound, sodium chloride. I hope that answers your question. Yes, I hope that answers your question. Hannah is saying thank you. PowerPoint slide, yes, it's on Canvas. I know it's going to be posted on Canvas. Yes, I'll try later on. Yes, I'm gonna make sure that you can rewind over and over. And I was asking if I can post later on the notes. That is true. I'm gonna make it available on Canvas once I convert to the, once I change and record it on YouTube, post it on Canvas so that you can revisit later on. Yes, I hope I answered your question on the definition of a compound. So here is a compound. H2O is a compound. It's made up of hydrogens, 2 hydrogens, and 1 oxygen. And this leads to what we cannot come back later on, the low definite composition. Mixtures, they have different properties. I had explained earlier on, mixtures, they exhibit more than, right? Their properties varies. They vary in composition throughout the sample. We have defined heterogeneous, homogeneous, shouldn't be hard for you. Homogeneous mixtures can sometimes be a solution. For example, here is a copper 2 sulfate, it's a solid. If you dissolve in H2O, you end up with homogeneous solution. Whereas the granite on your kitchen or countertop, it is an example of heterogeneous mixture, because you see it's not uniform throughout. I see there are some dark spots, all right, which means it's not uniform throughout. But this solution here, it is an example of heterogeneous mixture. Any question on mixtures? Somebody, if you are posting the PowerPoint slide, that is somebody saying that it's the best, is that the best to study for the exam or read the text? Either way, that question, Emily, I cannot say, you know, this is the best, because different people have different learning styles. Some people, they wake up 3 in the morning and they study, you know. Some people, they study 1 and they get it. Some people, they just listen to the lecture and they get it. They don't even have to read. They don't even have to take notes, and they know it. And, you know, it's gonna be boiled down to an individual preference. If you want to, you know, I'm fine, so long as you can master. But my recommendation is, you know, if you spend a lot of money to pay for the course, I will attend the lecture session, you know, I will read, unless for unforeseen reason, you know, ask question, and, you know, be well-rounded. Otherwise, if I post a PowerPoint, or if you study out of the PowerPoint slides, you know, it's not really conclusive. It is in the bullet point, all right? It may not be really, it may not really give you much information. For example, what I'm going through right now may not, all right? What I'm going through right now on the PowerPoint slide, if you go to the text, it will have more information, examples of heterogeneous, you know. If you look at the end of the chapter, problems, you should be able to answer the question by reading the text. Otherwise, in my view, the PowerPoint slide will not be enough for you to prepare for the exam. A good example is, we just went through the definition of homogeneous. We just went through the example of heterogeneous, but I didn't give you a lot of what? A lot of examples on that. So if you read the text, do the end of chapter problems, and then you will be well-rounded in every concept. I hope that answers your question. If it is the best strategy, well, some people will just read the text and they are fine. Some people will just listen to the lecture recording and they are fine. But if my chemistry is a little bit rusty, you know, I'll just come here and at the end of the lecture, you can say, hey, you know, I couldn't understand the definition of a compound, or can you walk me through this work example? And then I'll be able to really capture you know, really help you right away before it is too late, all right? That's my take on how to study. Any other question? Good, all right, moving on. All right, let's see, 1.3, properties of matter. What is a property first? A property is defined as the physical or chemical characteristic feature you use to define matter. It is the physical or chemical features you use to describe what? Matter. Physical. If I look at this paper right now, you know, you can tell me it is yellow, right? Or if I have my planner here, you know, by looking at the color, you know, basically you can say, oh, it is maroon, or it is red, it is green, by physically observing. A property also could be, you know, chemical reactivity of matter. For example, gasoline and H2O. How do you know which one? If I say gasoline is flammable, all right, and H2O is non-flammable. HCl is corrosive. That means, all right, it has to do with chemical reactivity. If I say nitrogen, or maybe group 8, argon is inert. Inert, that means it does not react. Those are chemical properties. So you need to know the difference between a property and a chain. There are two things here. Let me draw a parallel because we're gonna come back to that. There is the property here, which always confuse a lot of students. And then there is the change here. There is the change in terms of physical and chemical. So here I can say chemical property and physical. I meant to say physical here. I meant to say physical. And then there is the chemical. There is L here, chemical. And then there is the what? There is the physical change. We're gonna come back to this later on, but I like to have it parallel so that I don't get confused. For now, let's see the difference between physical and chemical. Physical property can be observed without changing the chemical makeup of a substance. You do not change the chemical makeup. Otherwise, if it's changed, that means, you know, it has to do with the chemical property. Examples of physical properties is color. You can say green, red, orange, or dua, yeah, maybe cologne, you don't change the chemical makeup of cologne, all right, or body spray. It's just gonna remain the same. Density is another example of physical property. Density of H2O 1.00 grams per ml. Melting point, all right, boiling point, hardness. These are examples of physical properties. You can observe, you can measure, but you don't change the chemical makeup of our substance. All right, this is an example of just distillation, separation of mixtures. Look at those later on. Let's see, how do you differentiate chemical property from physical? In chemical property, the chemical makeup of matter is changed. This property has to do with the chemical reactivity of matter. Examples is flammability. Talked about this earlier on. Corrosiveness, inertness, those are examples of physical properties of matter. When oxygen and hydrogen combine, but to produce H2O as a product, new substances are formed. Apart from those properties, I know mostly through experience, the first two you cover in introduction to chemistry, but in this course, this is the first time for you looking at this term, intensive and extensive. There is what we call intensive right here. What is the difference between these two type of properties? Intensive, this independent, look at what I have underlined, independent of the amount of matter present. Example is density. Density of H2O is always 1.00 grams per ml. No matter if I have 5 gallons or if I have 10 ml or if I have 2 ml, if I determine the density of those amount of H2O, I'll always end up with what? With 1.00 grams per ml. To be specific, the density is independent. We say that that is an example of intensive density. Boiling point, it does not change. Having 5 liters, 10 ml is still gonna have the same boiling point. Somebody saying that, are we, Emily, are we allowed to use written notes for quizzes or exam? In other words, you are asking if it is an open book, if it is an open, no, you're not allowed. It's gonna be, and that is why there is honor. It's gonna be proctored exam, all right? You're not allowed to use any notes. So it's not open notes. It's not open notes. It's not open notes. So quizzes, it's gonna be closed quiz. It's gonna be closed exams as well. All right. So that is what it is. Thank you. So back to intensive. Intensive means independent. This is how I talk. Look at I for intent and look at IN for independent. It does not depend. Color, for example, if I cut small piece of, if I cut small piece of paper here, it's still gonna remain yellow. It does not change the color. So ask yourself, when you are classifying a property as intensive, if it is independent or dependent. Extensive, this is why I look like extensive, like extend. When you extend like this, that means it's getting big. It depends on, all right? It depends on the amount of matter. For example, volume. Why is volume independent? If I have 10 ml versus 20 ml versus 5 liters, it is getting bigger and bigger and bigger and bigger and bigger. That is why volume is an example. All right, mass, you know, if you are in the lab and you are at the direction goal for 3 grams and 0.3 grams, those are just, you know, the amount of matter is 0.3 is smaller than 3 grams, all right? Mass is independent. It depends on, rather, extensive, it depends on the amount you have. Energy is another example of, you know, extensive property. This is an example of, you know, question on exam. Which one? We say that lead is dense than metal, than aluminum. We talking about extensive or intensive. This is density. I'll underline the word here. A dense, denser for density. And my, yes, you got it, B, B, B. Everybody got it right. Yeah, you gotta get an A. Look like everybody will ace the exam. So the correct answer is B. Thank you. Correct answer is B. So apart from, remember now, there were 2 types of properties, physical and chemical. There was, all right, intensive and extensive. How do you know that? You have to make your own notes. You can use, you know, plain paper until you really draw a parallel. It's not just what is a property. We get stuck, you know, there are 4 types of properties you need to know now. One is physical, chemical, intensive, extensive. When do we talk about all those? You know, you may be given all those 4 properties, but I'm looking for an extensive property of a substance. You should be able to understand that. Earlier on, I draw a parallel between this, all right, between a physical change and a chemical change. These are the physical you have to observe. But a change, you have to move from point A to point B. In change, you have to, let's say A going to what? To B. And then describe it here as physical or chemical. But here you are just observing or you are just measuring, you don't do anything. It is just right there. So what is the difference between chemical change and physical change? In physical change, all right, you only, this has to do with the changes, and during the change, the chemical makeup of substance is not altered. You don't change the chemical makeup of H2O, for example, if it melts. If I vaporize H2O to gaseous state, it will never change the chemical composition. It will still be H2O, whether it is ice, whether it is liquid H2O, whether it is gaseous H2O, the chemical makeup is still the same. But the changes there is physical. That means you don't change. Whereas in chemical, that is physical. Whereas in chemical, you do not, or chemical makeup is altered. So maybe here, I should write here so that you know what is meant physical change. Simply here, chemical what? Chemical makeup of substance is altered. That means you change, is change. Altered or change is the same thing for physical change. Whereas chemical here, whereas chemical, in other words, this change right here, chemical change, chemical makeup, all right? Chemical makeup is altered. That means you change. Chemical changes result in new substances. So you ask yourself, is something new formed? If yes, then just as a chemical change. Combustion, right, partner? or combustion in the internal engine of your car, automobile, or gasoline is burned. You can also look at this as irreversible. Irreversible, that means you cannot reverse. Digesting of pizza, for example, you cannot get back your pizza. Barbecuing, if you barbecue, all right? If you barbecue, it is a chemical change. You cannot get back your compound. Irreversible. The other one was reversible. I would also say this one is reversible. Reversible. You can reverse it, but the other one you cannot reverse it. Let me give you examples of physical change. If I have a solid here, I just give you examples of physical change. One is sublimation. We talked about that earlier on. Sublimation. Two, freezing is an example of physical change. Here, condensation. This is an example of physical change. For here, there is what? Condensation. This is condensation. We have deposition. 4, 5. There is melting. All right, there is melting. Deposition, there is condensation. We talked about condensation earlier on, all right? When something condensed, condensation. These are examples. Even dissolution here, dissolving, dissolving. A lot of students say, how can dissolving be, physical change? I thought it would disappear, like I dissolved sodium chloride and it's gone. How comes that this is a physical change? It is reversible. If I dissolve sodium chloride in H2O, I can evaporate H2O and get back my salt. It is reversible. If I shred small piece of paper, like shredding, this is an example of a physical change. Grinding, if you grind sugar to grind sugar to powder, it's just gonna taste sugar. You're not gonna change it. So those are examples, of physical changes. Now, on the other hand, what you see here is chemical change, combustion, oxidation. These are just a few examples. Is condensation, somebody say condensation there twice. Maybe I forget that. Condensation. Oh yeah, yes. Maybe I need to erase this. I don't need this. There is sublimation, deposition. 1, 2. What did I miss? There is something I missed. It should be 6. Melting, freezing. Sublimation, deposition. Oh, there is vaporization. I forget that. Yeah. You know that? This is what I meant, vaporization. From liquid to gas, I forget that. That's why I add condensation twice. Thank you, Andrew. That is what I know. There are 6 of them. So I had deposition twice. So these are examples of physical changes and chemical changes. Don't get the temperature confuse you, like how can it be physical? The temperature of H2O, if it is 50 degrees, it is 50 degrees. I don't change the temperature of H2O. If it is 80 degrees, I don't change the temperature of H2O, all right? If it is, all right, if it is volume, why is volume physical change? If I split my H2O here, I'm using water a lot. If I split this water into 2, I don't change the chemical makeup. Remember the chemical makeup? That's the fundamental question you need to ask yourself. Is the chemical makeup altered or changed? If yes, chemical change. If no, physical change. If I split this volume into two, I don't change the chemical makeup of my H2O. That is why it is classified as physical. So those are example physical change. I gave you examples of those. You should be able to have on your own. Here is an example of chemical change. Dropping a penny in concentrated nitric acid, all right, copper 2 nitrate is formed. That is a chemical change because it is irreversible. New substances are formed. It is irreversible. It is your turn. Is the following chemical or physical? Plants make sugar from carbon dioxide and H2O. Is it a chemical change? Yes. We are on cruise control. Good. I like that. It is a chemical change. Having a fundamental of understanding of what a chemical change, you ask yourself, new substances are formed, then you end up with that. All right, let's go back to now the mixtures. Remember on the flowchart of classifying matter, we had to zoom onto pure substances. And let's go back to mixtures. Mixtures can be separated into pure compounds, all right? There are several methods, all right, used to separate mixtures, be it pure or be it homogeneous or heterogeneous mixtures. You can use several methods. And in the text, you see on the screen, we have only 3 types of separation method. And I believe in organic chemistry, this is what you will use in separating your compounds in mixtures into pure compounds. In filtration, the solids are separated using a filter. You may recall from our introduction to chemistry lab or any lab you may have taken before that, you may have done the gravity filtration where you use a filter paper, or maybe vacuum filtration. Either way, those type of filtration you use you separate solid from a solution using a sieve, and whatever goes through, of course, it is considered as the filtrate. It's called the filtrate. Distillation is a method used to separate mixtures by virtue of their difference in boiling point. For this to happen, all right, your mixtures should have different boiling point. Alcohol or ethanol, for example, if I mix ethanol in my H2O, it will form homogeneous. Mixture, and I can separate those two: ethanol, that is alcohol, and H2O, because they have different boiling point. Ethanol, all right, ethanol. Let's see, ethanol with around 78 degrees Celsius and H2O, we can separate these by virtue of their difference in boiling point using distillation. If I have a mixture, raise the temperature to 78, I'll start collecting the ethanol, this one first, and then later on H2O using the distillation apparatus. You learn how to, set up these apparatus in the lab. You'll see cold water. So if my mixture here is ethanol and H2O, the one with lower boiling point will vaporize and it will condense. Typically, a thermometer is hooked up right here and suspended just above this mixture, and the temperature will be stagnant at 78 for some time while there will be some liquid being collected those is, and the temperature will remain at 78. Once ethanol is gone, no more liquid will drop and the temperature again will rise to 100 degrees, and I'll see some liquid just dropping. That will be my H2. It's just by fudge of the boiling point. That's how distillation is used to separate the mixtures. The other one is chromatography. Chromatography is a technique used to separate mixtures by fudge of their molecular weight, their affinity to adhere to surfaces, all right? There are different types of chromatography. Paper chromatography, all right? Electron affinity chromatography, but we're not going to go in details into all those, but have an idea of how it works is, if you have a mixture here, for example, let me give you how it works. If we have a mixture with different molecular weight, and, all right, this is a porous material. The less or the smaller molecule will go through faster. The heavier one will take some time to go through the column, this chromatography column, and the one will be eluded, call it elution fast. You'll see initially we didn't have, but you see they are being separated into three components. You can use, you know, masses, you can separate using masses, or you can separate using electron affinity. For example, if one of the components mixture is positively charged and the column is negatively charged, positive and negative to attract, but neutral molecule will go through. That's just to give you an example on how chromatography is worked. This is a technique used to separate based on the ability of substance to adhere onto the solid. Why is it adhering onto the solid? You may ask, why, what is it making? It is based on the chemistry of what you want to serve. It says, I gave you an example. If one of the components is electrically charged, if it is positive and the column is negatively charged, positive and negative will attract, and it's gonna be on the surface. That's basically chromatography and the separation of mixtures. Let's take a 5 minutes break. I'm just gonna take a 5 minutes break and I'll come back to, all right? I'll come back to this section. Take 5 minutes break, grab a cup of coffee, don't call, because I'm gonna take a roll call. And I don't want to drop you out of class. There are a lot of people on the waiting list. If I drop you, somebody will just come in and it's gonna be very difficult that, oh, you know, you are not in. I drop, you know. So after 5 minutes, we're gonna get started. 5 minutes. All right, I'm back. I'm back. What I'm gonna do now is let's see. I don't want to drop. I don't drop anybody. What I'm gonna do now is take the roll call. I will unmute everyone and just say, just unmute yourself. Just unmute yourself, please. And I'm gonna call the names real quick.
Oh, I see.
Hello.
Okay. Okay. Hola, ¿cómo estás? Estoy aquí.
Hello.
Hi.
Hi.
Hello.
Hi.
Hi.
Uh-oh.
Hello.
This look like some people are. Hello.
Yeah.
Yeah, I wanted to take a roll call. Some people they are, they are on their. Some people they are on their with their families, and I hear some background. I wanted to take the roll call, but I guess the class ends in 5 minutes. But because of the nature of the background, I will use the assignment for attendance. As I said, I don't want to drop anybody. I'm required to report whoever I've done any work in the course so that you stay. What you will do is do the assignment, the course assessment. I'll post the assignment. Please do that. And then I will use that as attendance that you have done something in the course. Otherwise, if I don't see the assignment by Friday, it's just gonna be a simple thing that you have read the course syllabus and be able to, I'll be able to use that. I'll create and put the grades on gradebook, and I'll use that as a check for what? For work. Thank you. Everybody put it here. All right, everybody put it here. And I think the class is ending at what? In 5 minutes? I think it's 12:30, not 12:50. We start at 10:50 and we are ending at 12:30. We have about what, 5 minutes. I wanted to put manually the attendance sheet that, but you could hear, some of you could hear that there was some background. I don't know where it was coming. Please put it on the chat that you are here before you leave. We got about like 5 minutes, and that is it for the day. On Thursday, we'll start from what? We will start from section 1.4. In the meantime, please read chapter 2 and chapter 3. Please read chapter 2 and chapter 3. I'll make the PowerPoint slides. So if you have marked yourself present on the chat feature on Zoom, the class is dismissed. I will see you on Friday, on Thursday, same time. Please mark yourself as here on Zoom. I'll go back later on and mark you as present. Otherwise, if you have done so, the class is dismissed. I'll see you on Thursday. Please read. I'll make the adjustment on Blackboard as far as the assignment is concerned. Thank you for tuning in today. I really appreciate. We are almost advancing towards the end of the semester. I really appreciate. Do take care. Social distancing. Stay safe. But I miss seeing you in class face to face. Hopefully we'll be back in 4. All right? By count of 1, 2, 3. The meeting, I'm gonna end the meeting in a few minutes, please. Thank you again. We will meet on Thursday, all right? Thursday, same time. 1, 2, 3. Thank you for tuning in.
Thank you.
The meeting is ending right now. Thank you.